Hi, I'm Gus on top of the secondary one for NS High School. Right now here, it is about ordinary differential equations. Well, ordinary differential equations, right now, we're at the part for our operators. But for our operators in this part that we're going to have, well, we have proved quite some things before, right? So, we'll try to use them into different examples, alright? So, let's just take an example. Let's just take a look at this example. So this example here, d minus 3, d plus 1, d plus 3y is equal to 3 sine 2x plus cosine 2x. Alright, so this is the ordinary differential equation that we'll get. So if you have forgotten what's d, you just take it as d over dx. So if you have one of this, then it's first order. 2 of these times together, second order. 3 of these times together, third order, and so on. Alright. So from here, the part that we're going to use. We're going to use, well, sort of something different because in this case, what we're going to have will be, we're just going to so let's just say we have done for d subtract 3 first. So the remaining parts are these parts, right? So for that part that you have done will be, we'll just call it y1, okay? Then same when you continue to do, at last you'll get d plus 3. So after you're finished with d plus 1, we're just going to call it y2. Then at last, you have y, right? So this is just the order that we're going to solve it in. Okay. So firstly, in this part, we have to find for y1 as what we say. So y1 in this part, that means you divide this to the other side. Wait, it is not co2x. It is cosine 2x. Then you have to over d minus 3. So what can we use at this part here? Well, this part here we see sine and cosine, right? How about let's try to get rid of this denominator first. Well, it's something that we have done for the past few lessons. So here we try to get either square or even power or just constant. So that's what we're trying to get for here. Then above, we just need differentiation. So from here, that means we can denominator, or we just think that we times something in the denominator and then times something in the numerator. As we've actually proven that we could have it as differentiation, integration. Then you have both of them together, alright? So from this part, differentiate, that means you will use d plus 3. Then 3 sine 2x, then plus cosine 2x. Then over. So from these two parts, you could think of them as combining. So that means what you get will be d squared minus 9. Alright, so d squared minus 9, that means, okay, d, what we're subbing it in as will be a 2. So subbing d as a 2, that means 2 to the power of 2, 4. But at last you still need to add that negative. So that means in the denominator what you get will be negative 13. Okay, then differentiation, and in this part is the sines and cosines. So differentiation is the next part. We first differentiate with this. So, okay, 3, then chain rule, you get another 2. Then you have 6 cosine x. Six cosine 2x. After you have to subtract 2 sine 2x. Alright, Then for your 3, so we add 9 sine 2x. Then to the next part, you add 3 cosine 2x. Okay, wait. Since at first you didn't have brackets, so here you also don't need the brackets. So this is the part that we're going to get for y1. Well, just a little bit of combinations and simplify if possible. So for sine 2x, what you get will be 7 of them at last. Then for the other part will be 9. So both of them are positive. So 7 sine 2x, and then you add 9 cosine 2x. Okay, so this is a part that you're going to have, alright? So this is for your y1. Next, you have y2. So when you're going to have for y2, this part that you're going to have, well, you could just think of it as, okay, we already have this part, then you could integrate for d plus 1, again, like that, okay? So, negative 1 over 13, then 7 sine 2x plus 9 cosine 2x, then over d plus 1. So, at first, we just write it out in the operator's form. This is what you have. Then, in the next part, you can start your, well, integration. We can just use the same method. So, differentiate, integrate, then for the integrating parts, we just combine them together. Then, you just get something else. So, in this case, when you have d minus 1, okay? So d plus 1 and d minus 1, you get d squared minus 1. Okay. This bottom part you can calculate it. We're just taking d squared as a negative 4. So for the denominator, in total you have negative 5. So negative perfectly, you can combine it with the front part, which is 1 over 65. Then from here, differentiate 14 cosine 2x. Then differentiate negative 18 sine 2x. Then you just times a constant, negative 7 sine 2x and negative 9 cosine 2x. So this is what you have. Then you can make a little bit of combination. So for cosine, you'll get coefficient 5. Then for sine, you get coefficient negative 25. So both of them are actually multiples of 5. As both are multiples of 5, we could simplify. So you have 1 over 13. Then, so we simplify them. Cosine, you'll just be left with cosine 2x. So sine, you have negative 5 sine 2x. So this will be your y2 that you will get. The last part, well, you have already done for 2 of them. Now is the third. You may call it y3, right? But let me just tell you, since at y3 is when we have our last, well, you can call it integration, or you just change it into a differentiation. So this is actually our y. So our y will be for y3, alright? Which will be, so in front, 1 over 13, this part over here. So over d plus 3. So this part now. So d plus 3. Then that means right now here we need d minus 3 for both. If we're using d minus 3, okay, so above we can just remain the same. Then below, what you get will be a d squared minus 9. Alright. The next part, for the denominator, you could change it. So the denominator part, you change it into negative 13. So 13 squared, you could just calculate it out, 169, or you could just write it as 13 squared. Then above here, we'll have the differentiation part. So the first one, you get negative 2 sine 2x, differentiate, negative 10. Okay, it becomes cosine. Negative 10 cosine 2x. Then negative 3 cosine 2x and a positive 15 sine 2x. So this is the part that you'll be getting. Let's take a look at sine. So sine, that means you have 13. Cosine, you get a negative 13. So from this part, at the last part, well, we have to be extremely careful here. So negative, and then you have positive sine, negative cosine. So I'm just going to first write down if you have a negative 1 over 13 squared in front. So behind there you'll get 13 sine 2x, then negative 13 cosine 2x. Then next, we can simplify because both of these, this is 13. So yes, you can simplify with one of the 13 you have here, and then negative, you can put it inside. So that means at last here 1 over 13, what you will have will be, so negative, that means it is positive, wait, you simplified it, that means it is cosine 2x, and then negative sine 2x. So this would be the answer that you get at last, right? How about let's make a verification just to verify that it is correct. Alright, so for this verification part that you have, first of all you can find for d, wait, how about let's go from back to front, or you can also go from front to back, like d minus 3y, then what you will get will be, so d, that means differentiate it, but 1 over 13 will stay outside. So differentiating it, you will get negative 2 sine 2x, then you subtract 2 cosine 2x, then for your times negative 3, which will get negative 3 cosine 2x, and positive 3 sine 2x. Okay, like this for the first part. Then the next part is sine and sine, you get 1. Cosine, cosine, you get negative 5. Okay, so this is the part that you'll be getting. The next you could add on with d plus 1. But d minus 3y, we could take the previous part that we've already got. So d plus 1. That means first of all, you still have to differentiate it. So differentiate, that means 2 cosine 2x. Then you add 10 sine 2x. Then afterwards you have to add 1. So plus sine 2x. Then minus 5 cosine 2x. Okay. Then equals. So what is this part here? These two you get negative 3, these two you get 11. Okay, so this is the part that you get. Then for the last part that we still have to differentiate will be d plus 3. So now we'll add on d plus 3. So 1 over 13, then d plus 3 in this part. Alright, you can just use this, then differentiate on. So differentiate, then you get 6 sine 2x. You add 22 cosine 2x. Then you times the 3, you get negative 9 cosine 2x. Is it alright? Then you add 33 sine 2x. Okay? So from this part, what you get? You get 13 cosine, add on, okay, 39 sine. So 13 will be fully simplified. Since here you'll be left with 3 sine 2x, well this part you'll be left with 13, that means it's 1. So just add cosine 2x. So when we take a look at what we have at first, is it the same? Yes, it is the same. That means this part is wrong. I mean correct, okay? So this is verified. Okay, so this part is correct. So we could use this method for similar questions. So if you could understand it, good for you. So I'll just be ending this lesson here. So if you like our videos, don't forget to subscribe to our channel. See you in the next lesson. Thank you for your watching.